We've spent the last lectures inside the heart itself. We followed electrical activity as it starts, spreads, and travels through cardiac cells. But now a question appears. How does a machine sitting outside the body know any of that happened? Because the ECG machine doesn't actually see the heart. It sees the direction electricity is moving. The ECG looks at the heart via electrodes. The electrode is a small sensor placed on the skin. Its job is simple. It detects electrical potential at the point where it's sitting. It picks up the electrical signal coming through the body from the heart. Think of it like a microphone. But here's the thing. A microphone in a room tells you sound is happening. It doesn't tell you where the sound is coming from or which direction it's traveling. An electrode has the same problem. It can tell you electricity is present, but it can't tell you anything about direction. Not yet. To detect direction, you need something to compare against, a reference point. You need to ask, relative to what? So we give the electrode a reference, usually another electrode. We designate one point as positive and another point as negative. The line drawn between them becomes an axis, a defined direction in space. And by convention, it points toward the positive pole. Now the electrode has something to report against. It knows where it's standing. It knows which way it's facing. This pairing, this axis between a positive and a negative pole, is what we call a lead. And now the rule becomes possible. If the wave of electricity traveling through the heart is moving toward the positive pole of that axis, the lead records an upward deflection. If the wave is moving away from the positive pole, downward deflection. If the wave is moving perpendicular, neither toward the lead nor away from the lead can't decide. The deflection is flat or briefly biphasic. Toward the positive, up. Away from the positive, down. This is the rule. And it only works because the lead gave the electrode a direction to measure against. The wave itself hasn't changed. The same electrical event is happening in the heart. The only thing that changes is the angle you are watching it from. Now here is where things start to make sense. The ECG doesn't use one electrode. It uses 10. These 10 show us 12 leads. 12 different angles, all recording the same heartbeat at the same time. And so when you look at an ECG strip and you see that the same beat looks completely different in different leads, that's not an error. That's not 12 different things happening. It is one electrical wave seen from 12 different perspectives. Imagine you are filming a person walking across a room. From the front, they're moving toward you. From behind, they are moving away. From the side, they seem to barely move at all. Same person, same walk, 3 completely different videos. That is exactly what 12 leads are doing to your heartbeats. All 12 leads fire simultaneously. They record the same electrical event. They simply disagree on whether it looks positive or negative, because they are watching from different directions. So, what does the ECG machine actually do? It places detectors at specific locations on the body. Each detector pairs with a reference point to form a lead. Each lead watches the heart's electrical wave from a fixed angle, and it draws a line, up or down, based on whether that wave is coming toward it or moving away. 12 leads, 12 angles, 1 heartbeat. Now you understand what the ECG is recording. But there's still one thing we haven't talked about. The paper itself. What do the squares mean? What is time on this paper? What is voltage? Because until you understand the grid, you can't measure anything. That's next. That's all. Thank you, and see you in the next lecture.